Okay, Russ.
All right, thanks, Ron. Well, again, please welcome Doug Sandmeyer there. I've said this 1,000 times, but one of the good things for us coming out of the pandemic is that we can get people like Doug from another division giving us a presentation, and I think you heard where our Bruce the mayor gave one to them today. So it's pretty neat the way it works. So Doug, uh, thank you for being with us today, and I'll let you take over.
Okay, thanks, Russ. I hope everybody's hearing me all right. I just kind of curious as to how many of you might be NCE users, and oh, nobody.
No, we have quite a few.
Oh, okay. And how many might be familiar with the Light-It already?
I see one hand. I see one hand here in the room.
I got one. Is that for signaling, Fred, or is that for interior structure?
Lights.
Lights. Okay. Okay. Well, I guess started here. Oh, it's not moving. Oops, there we go. Wants to use the mouse. Okay. So we're going to take a look at using the Light-Its for structure lighting. And I thought I could use the keypad for this, but I guess not. So a little background first. My interest in model railroading started with perusing my dad's old model railroaders and seeing pictures of the gory and defeated all lit up for the nighttime running shots, and a little Lionel train business thrown in. So I've always been a fan of lighting the layout. I think it adds a lot. And so I've looked around at various means of lighting and trying out different approaches here for controlling the lights. When I was thinking about this years ago, we didn't have Light-Its, and so there's a thing like a cam timer that clockwork mechanism spins a drum with contacts on it, either contacts or cams, that operates the lights. And of course, we all know what happens when you run wires to every structure, and trying to add any kind of effects to that structure would require a circuit for each lighting output, I guess. So that's kind of a problem. So I discovered the Light-It, and that's produced by NCE. It's small thing about the size of a postage stamp. It operates as a DCC accessory decoder, a mobile decoder, or a signal decoder. And I use it in the mobile mode. You have 3 5-volt lighting outputs that are rated at 10 milliamps each. They have 330 ohm resistors on board, so you don't have to add resistors for your LEDs to have them operate at the correct current level. There we have 15 independent effects that you can use for adjusting the whether you want flashing lights or blinking lights or rapid flashing, strobe. There's even a and B output that you can use for grade crossing signals. And each of those 3 outputs can be set for any one of those 15 effects. You have adjustable brightness, so you can control the brightness of each LED on the output. And you can turn the outputs on and off individually with function controls. You can operate it in a DCC or that is with DCC. I'm sorry. There is a DC mode that doesn't give you the ability to control the outputs. And it includes 2 through holes for adding a capacitor if you were to say want to use it in a passenger car or a caboose as a keep alive, in which case consisting is possible in the mobile mode. So you could operate your passenger cars as a consist or a caboose with a locomotive. There's the dime for scale, as these things are tiny. So you can fit under buildings or in buildings, in passenger cars in the roof. A lot of places. The lighting effects that are available are these: the steady on, the slow flashing, fluorescent fixture. Some of them are useful for buildings, some of them not so much. I've got a string of street lights that I use. I don't see it here now. It's a failing light. So it comes on and then it slowly flashes off, and then a little while later it blinks back on again. So you've got kind of a failing street light, I guess, effect.
Hey, Doug.
Yes, sir.
Russell here. I'm sorry to interrupt. If it's possible, I just, while you had such a big view of the Light-It there on the previous slide.
Sure. Oh, you want me to go back?
if you can, I just,
yeah, there you go.
So in other words, I didn't know if you were going to show this again later on, but the holes are those the soldering lugs that you would put whatever lights to it?
Yeah, these are the output lights, and I'll cover the which one's which. The ones in each corner are for the DCC bus, and excuse me, the ones down here, there's an option for a remote program button.
Okay. All right. Thanks. I didn't know if that was
no,
come up later.
That's okay. And I don't think I cover it later, but if you're operating it in the DC mode, you can control the brightness with this small pot in the bottom right-hand corner here.
Thank you.
And while I'm glad you asked for this, because while I've got this up, here is onboard LED which operates as one of the outputs. So you'll see an X on the board, and if you cut this trace, you drop this output or this LED off, and then you're using the first output on the through-hole connector. So obviously you have to have magnifiers. Oh yeah, that's fun working with magnet wire, as I'm sure a lot of you are aware. So okay. I don't know how I'm going backwards there. Okay. Okay, so we've got more now. This morning I watched Bruce's presentation on his fire hall, and I'm thinking Bruce isn't going to be interested in this if he's only got 3 outputs, and they're rated at 10 milliamps each. But NCE has another device called the Illuminator, and this is got 100 milliamp outputs, 3 of which. And there are no current limiting resistors. So you can pile on the LEDs, but you still only have control of 3 distinct outputs. It's also designed for use with Woodland Scenics products or anything that you need more power for. So we'll touch on that a little later. Tools, you need a small soldering pencil, rosin core solder if you're working with electronics, I found that desoldering braid or a solder sucker is nice if you make a mistake and you need to clean out the through holes. I use tweezers, clips, wooden sticks, anything I can to hold the wires in place while I try and solder them, either to the Light-It or to the sides of the buildings. There's Captain tape, a receiver mounting tape I use for mounting these frequently. I just stick it on the back, and I'm trying to do most of the Light-It mounting on the bottom of the building where I can get to it later. Magnifier helps. You always want to test your LEDs before you get them in there and wired up, because you don't want to have to tear apart a building to pull out a dud. And a wire stripper for small gauge wire. I've found that as far as strippers go, I use that for the wire that powers up the Light-Its. It's anything I've been doing with LEDs is so small. I usually find I can strip the insulation off the enameled wire, and even some coated wire with other materials with the tip of the soldering iron. X-Acto knife, sandpaper, masking tape. I've kind of gotten away from those items now that I've discovered I can do a pretty good job with just the tip of the soldering iron or pencil. Frequently I'd tried to use an X-Acto knife or sandpaper to scrape the insulation off, and that just ends up nicking the fine wire. And I've got a collection of small gauge wire in different colors to try and keep things color coded. Glue, of course. And here's some of my wiring aids. This wire I found at the local hobby shop. It's sold by Brawa, I believe it is. It's a German, and it's a excuse me, probably a 22 gauge, maybe 24 gauge wire that has a nice flexible jacket on it. So for longer runs to the DCC bus, that comes in handy. There's some of it now here, over here on the right. And let's see if I can. Yeah, there we go. Over here, you'll see shrink tubing, which comes in handy. And I've been buying these dip single, SIP headers. They're a single inline package. They plug together, and you'll find them included in some decoder sets and that, but these come in different length bars, and you can score them with a razor saw or something and then snap them off like I've done up here, solder them up, and then they make nice connectors for plugging in buildings. This little guy up here is a circuit board that's a SMT or surface mount board for hooking surface mount devices up to through hole connectors. And these through hole connectors are in the same spacing as the headers down below. But I don't know if you can see, there's little mounting pads, so you can put surface mount resistors on there, and this makes a nice device for building lighting, or even I've been using it in wiring up locomotives where I have a collection of resistors and wiring, because we just run the decoder output to one side and the lights off the other side and put in whatever resistor value I need. This is a device that's board that's sold by TCS that has 4 solder pads on it, and they're all interconnected, so you can use it for a kind of a bus. Okay, so wiring the decoder. The DCC in is from the rings on the top or bottom corner. It's DCC, so that's not going to matter. I believe it doesn't even matter if you plan on using it with DC. The LEDs are on the 4 through-hole connectors on the top of the board, and they are common anodes. So your plus wire would go in the rectangular or the square hole, or square solder pad, I guess, and then the other 3 are in line after that. The first one you encounter on the left side is the white or green, and these are identified by what they would be used for if you were using this as a signaling system. So we've kind of carried that through with my labeling of the system, so I keep things straight. But you have the white or green, and then the yellow, and then the red output. Across the bottom, we've got one of the DCC inputs. There's your LED that's on board, and the trace that you cut if you want to use the white-green output up here. And then these 2 down here are for a remote program mode. If you put this someplace where you can't get to it, like maybe inside a passenger car, you could probably run these leads out and have a switch of some sort, so you can reprogram this thing if you need to. And there's your DC trim pot on the right here. And these, let's see. So before you do anything with this, you need to hook it up and give it an address. And we use this gold button for the initial programming of the Light-It. So you can figure out where your lights are going and plan on wiring and where you want to locate the Light-It. So once you cut this trace, this LED is not going to work again unless you bridge that with some solder later. And remember to allow access to your gold button, either by way of removing a roof or putting this under the building, somewhere that you can get to it. And wire or as you go, test as you go, so you don't have to go back and fix it later. Okay, programming it. I guess the video started, but this is the programming sequence. Once you press the gold button on the Light-It, you have 60 seconds to finish the programming. And while this is an NCE product, I'm guessing it can be programmed with anything that you can use the program on main command for. They don't want to be programmed on the test track. So you see, you press the gold button, then you select the loco that you want your new address to be. Hit enter and select program on main. Just going to pick CV1 and select a value of 1, and then enter, and then the blinking light should stop and you're programmed. So that's the textbook method. And when I started doing this originally, I was having trouble getting it all done in 60 seconds, trying to figure out where everything was. You can do everything up until pressing the gold button, and then press the gold button when you're done selecting the loco and everything else. And then you can sit around for 60 seconds and wait for it to time out. So it takes the pressure off the. Okay. It's also programmable by the later editions of JMRI. And while it's easy enough to program it just with the handheld and NCE or whatever your system of choice, you find that the JMRI program lets you assign a name to it and keep track of what you've done in the way of programming it. So you can, once you get the initial naming set up in that, you can start setting up your outputs. There's the, I've got these color coded with a highlighter here. The green output is on function 0. You can change that. You can set the program here is set for effect number 1, or the steady on. Function 2 is set for steady on also. The yellow output and the red output is also set here for steady on. And that can be changed. Here's your white, green brightness level, yellow brightness, and red brightness is set for the factory default right now. That's one of the nice things about this, is if you want a structure to have a living room light that's brighter than a bedroom light, you just come in here or dial up your CV code and enter the appropriate level of lighting. And here I've changed it to a little less than half brightness. Still with the basic program, your white, green, slow flashing, yellow is programmed for steady on. You just go through this and set it up however you want. And function, you can change the function that you want to operate the output. So here I've got 132 is the function number, I believe, and you can set that for anything from, what is it, 1 or 0 through 26, I believe. So if you had a collection of buildings and you wanted to run 26 or have some different circuits, so you weren't controlling all of them at the same time, then you could set up different functions for different rooms or different types of buildings. And there's your effects, and the brightness level can be changed here. Yeah, it looks like I'm going backwards. Okay. I found it helpful to keep track of function assignments and the DCC address, the building that or model type or name, and your relative output, which is, it's going to say what the Light-It thinks it is, and then this would be the function that you've assigned to it, and then brightness level and effect and the room. So I've got it by bedroom, porch, light, and the living room. So the bedroom is function 2, the porch is function 1, and the living room is function 0 in this particular structure. So let's say you have a large structure. You might want to use more than one of these. So here we can wire it up off the bus. Each one could be off the bus. Say, like, maybe this is 2 separate buildings. So you'd have your plug here and plug in building A here on the bus, plug in building B down further on the same bus, and you can assign them. If you want, you could each have their own decoder address. If you wanted to do a larger structure and you wanted to use 2 of them, you could wire them up like this, where you daisy chain them off of each other. And then you might assign the same decoder address to them. But now, instead of function 0 through 2, you could go 0 through 6. So that gives you the choice of maybe you want to have 6 different types of lighting on your building, or 6 different rooms that you wanted to operate independently, or exterior lights, whatever. In which case, where I've had groups of buildings, I've used the dual inline package, which you're familiar with ICs that would use a similar package structure. And then I've used the small plugs to plug each building into the larger socket. eBay is a good source for LEDs. They're pretty cheap. I don't know the seller I was using, I can't find anymore, but I found lights on Amazon that are packaged almost as reasonably priced. I've been buying the 400 series LEDs, which are extremely tiny, great for HO, probably even N. And Woodland Scenics, you have the Woodland Scenic series of lighting devices. These are the street lights that I've used, and you can plug them directly into the illuminator. Now, NCE has done something. I'm not sure who made the mistake first, but you'll notice that the red and black wires are swapped on the outputs. For the pigtails that are not connected to anything come with the illuminator, and the other package comes with the Woodland Scenics equipment. So you have to be careful, and Woodland Scenic or NCE covers the discrepancy in the instructions that come with their illuminator board. This is just the size of the 400 series LED that I picked up from CMR Enterprises, another supplier for that. Okay. Yeah, the Woodland Scenics does carry the current limiting resistor in their wiring harness. The NCE wiring harness does not include that. So if you're using the illuminator for something other than Woodland Scenics, you'll need to figure out the resistor that you need. So these are 12-volt outputs on the illuminator. Okay, stripping the magnet wire. There's scraping it off, which I think I said earlier, that doesn't work so well. You'd end up shortening the wire every time you nick it. Just using the soldering tip to heat it up and melt it off. You put a little blob of solder on the tip and then pull the wire through the blob of solder, and it seems to do a pretty good job of cleaning it up and tinning it. So how do you deal with this little stuff? Well, tacky glue, fast drying works good. Hot glue works in some places. I've used tape. I've weighted it down with different things just to keep it from wandering away from me while I'm trying to connect it to the circuit board. These I should tell you ahead of time so you don't think I'm crazy. These are O-scale structures. So these are actually the Campbell brass lamp shades for HO scale, which work great in O. And then this is the engineering tubing. So wiring up residences. So the 3 outputs, I've got it hooked up so that I've got one on the porch, one in the bedroom, and one in the living room. And when I got all the LEDs in there, I discovered the leads weren't long enough to reach the circuit board where I wanted it. So I had to get my little alligator clip thing here to hold it in place while I connected up the leads. It's a situation where I use the, instead of wiring up an LED, I use the onboard LED for the white-green output and just stuck it to the ceiling in the house. And with a magnet wire, you know, it's easy to cover up your tracks with tape or paint even. Okay, so there's a mine tipple that I've got, and 3 outputs wouldn't cover the exterior lighting, so I've hooked up 2 of these. I ganged them in daisy chain, and then I've used a soldering pad here, circuit board, to connect the heavier wire to the magnet wire. And that's glued someplace where hopefully nobody will find it. There's a situation where I only needed 1 light, so I just wired it to the bus and then attached it to the top of the building, or the interior, the ceiling. Oops, why won't that go away? There we go. It's a gas station that I built, had already been wired up, and yeah, it was going to be too much for the Light-It to handle, so we used an illuminator for that one. 4 LEDs were wired in series, which I don't think I'd use that configuration again. But the building that you saw at the beginning of the presentation, there's several lights in the interior. The ceiling lifts out here so I can get to it, to the interior of the building for detailing it. And then there's a connector between the fixed portion of the entrance to the Light-It. This fits in an O-scale caboose anyway, in the cupboard in the middle. And here I've hooked up the 2 little capacitors, so it has the keep alive feature. I was able to put the LEDs into these 2 little marker lights, and I didn't get them the LEDs oriented as well as I wanted to, so I was able to use the adjustable lighting output to get them the brightness so they appeared to be about the same. Okay, using it with DC. Even though most of the buildings, or all my buildings, are going to be DCC powered, it was nice to be able to use it with DC. I could take the building off the layout, and I built a small power pack. I can take the building to a show and it'll light up. It won't have all the control that it does on the layout, but I can show the judges that, yep, it lights up, or the public. So I've come up with a couple different schemes, and I haven't really settled on one yet for using the LEDs on the layout. One is to give each one its own, each building its own address, which I think would get kind of cumbersome after a while. And this just runs through. I built this test board to demonstrate this, but we'll kind of skip that, I guess. So here's three Light-Its on the same bus, and one is look address 10, one's 20, or I'm sorry, one's 10, one's 30, and one's 40. And let's see if we can. So by using the different functions, you can, like we're selecting 10, and then you'll see the LEDs come on. Go to, well, I've got my text wrong because I see address 20 selected. I'll see some different functions with these as well. And each of those three are just using the three functions, L or 0 and 1 and 2. The other option is to use them as kind of a consist and give them all the same address, in which case you would just select the decoder, which is 10, and then you can walk through the all the outputs. So at present, my layout is using one address, which happens to be 1000. So I don't think I'll ever have 1,000 engines. So that's a pretty safe bet. And they all have the same address. And I have 26 functions I can use. So different types of buildings. I'll have commercial buildings might be function 10 through 15. Residences might be functions 0 through 10. Commercial buildings, or I don't know, commercial or industrial, I've separated them, so they'll have a different range of functions. So you can just, when you decide to turn the lights on, you can just turn them on in whatever order you want, or turn them off in whatever order you want. Now that we have Wi-Fi throttles, it makes it a little easier, because now you can actually label what your functions are controlling. And this is not my setup. This was a copy and paste into these pads here, but so I've got R for residence, and this would be living room. This is outdoor, residence bedroom, residence kitchen, and then I have a commercial category, indoor, outdoor, and an industrial, indoor and outdoor. This would be like atmospheric lighting, maybe like street lights. And so this is only 1, 2, 3, 4, 5. This is only 10 out of the 26. So he can have a lot of fun with that, I guess. And I thought this might be good for anybody that has small children visiting them, that you could hand them a Y throttle and ask them to man the lights for you. So this is a lighting sequence using 3 functions. This is no lights. And there's the first function, lights up a couple of the structures, and then second one, you've added a few more. And then there's going the other way with the outside lighting on a lot of the structures. And that's with everything on. So what's next? Well, I think the Iowa Scaled Engineering has brought out the motor men that I believe can use auto functions on on mobile decoders. So you can, if you happen to use the motorman for controlling a animated scene, you can run the light features off of that. At one time, I was going to try and use the NCE controller for, I think they use it mostly for switch routing and that. And I found out that that will not control functions. So that was out. And then there's the Arduino, which someday may present a possibility as far as controlling these things using some kind of a real-time clock. But that's off in the future. And remember to check with the code officer having jurisdiction before you put anything into practice. So that concludes the presentation.
And thanks for sharing it with us.
Yeah.
Oh,
Yeah,
you're
Doug,
welcome.
thanks for your time today. We appreciate it.
Okay, and with that, that's the end of our time together. We'll see everyone next Saturday at the train show and sale. Oh, yes, Russell, don't forget to visit Russell. But don't park unless you want your tires sliced on the right side of the driveway.